Hello, my name is Johan Lopez. I'm a staff solution engineer at Qt Group, and today I'm going to talk a bit about our Eclipse motorcycle instrument cluster demo. As we're seeing in many industries, like especially automotive already for several years, now we're seeing a trend in the motorcycle industry where there are more and more displays also being added with larger and larger size and resolutions and more feature-rich functionality and user interfaces. So especially in the realm of urban mobility, we're seeing manufacturers trying to replicate a user experience which is similar to smartphones, because that's what people are used to on a daily basis, especially with the younger generations. Implementing this kind of user experience for motorcycle displays is not that easy. There are many challenges that the teams working on this face. The first one is cost. It's always a challenge for many types of products, but especially in this case. So it's important to choose a hardware and software solution that can really minimize the cost. The second challenge can be, for example, battery usage. So many of the vehicles are battery powered, so it's important that the solution is also power efficient. At the same time, development team face other challenges with development time, so it's important to have a product that enables them to have fast time to market, because the market is very competitive, and also having powerful tools to implement the vision of the designer without compromises on the design. Together with our partners Infineon and Crossware, we've been working on implementing a reference instrument cluster application that demonstrates rich features like map navigation, 3D animations, or complex menu interactions. This application is running on an 800 by 400 display driven by an Infineon Travio 2 microcontroller. It's a dual-core Cortex M7 with a pretty powerful graphics processing unit. So we're seeing, for example, here a cinematic startup animation, complex 2D and 3D content, as well as different types of animations. The most interesting feature in this demo, though, is the map navigation. Implementing this kind of feature on a microcontroller brings a lot of challenges, the main one being the memory requirement that it comes with. So for this demo, what we decided is to take a different approach, to actually create a smartphone companion app that can render the map with ease and then stream the content to the embedded device using Wi-Fi or Bluetooth, sending over compressed JPEG frames. This streaming feature can be used as well for sending other kind of content to the embedded device. For example, it could be your favorite music streaming service. So what's the performance level of this demo? Well, we can achieve a smooth 60 frames per second across all animations. And when it comes to memory, it only takes 2 megabytes of RAM and 5 megabytes of flash. As for the development time, it took us around 1 month of design time and then 4 months of development time for the Crossware team to implement the full application, thanks to the Figma to Qt plugin as well as of the Qt for MCU framework. I hope you enjoyed the presentation. If you want to learn more, reach out to us or our partners.